Hello everybody, this is the notes for section 13.5 for Algebra 2 Trig. Alright, what we are talking about, or what we have been talking about, is all the trig functions and the unit circle and radian degrees. So now we're going to kind of shift gears a little bit and talk about the graphs of these trig functions and what they look like. So I'm going to show you the graphs for the sine, cosine, and tangent on a different program. So what we're looking at here, on the left side, we've got this unit circle. All right, you can see in the green up here, we got a theta value. Okay, so what I'm going to do is just rotate, move that, and it's going to rotate the radius around the unit circle. On the right side, the x-axis, that's the angle measurements. So as I rotate from 0 to 90 degrees, we're going to be moving from the origin on the x-axis out to 90 degrees on the x-axis. Okay, so on the unit circle, we're talking about the sine graph here. So on the unit circle, the sine was the y-coordinate. So what I want you to do is think about, as I move this angle, pay attention to the point. As it rotates around the circle, you're looking at the y-coordinate of that point, okay? That's what's going to produce the sine graph. So right now, at the starting point in standard position, the y-coordinate is 0. As I move the angle, going up to 90 degrees, the y-coordinate is now 1. So we've rotated 90 degrees, the y-coordinate has gone from 0 to 1. That's what's making this graph. We went from a y value of 0 up to a y value of 1 at 90 degrees. And I'm just going to keep on rotating. As we go from 90 degrees to 180, that y value is going to go from 1 back down to 0. Okay? As I go from 180 degrees to 270 degrees, the y-coordinate is going from 0 down to a negative 1. Get it back to 270 there. Okay, let me move this recording thing. And as we go from 270 back around to 360, our y-coordinate is going to go from negative 1 back up to 0. This is where the sine function, or this is what the sine function looks like. Okay, this is just one period of the sine function, but you get the idea of where this graph is coming from. If you think about that unit circle, the sine values, again, are the y-coordinates. This is what the y values do as you rotate. And so instead of thinking of the angles going around the circle, put those angles along the x-axis, and now you've got your sine graph. All right, so let's go back to the notes. All right, the key thing here, the sine function, that's the first one we'll draw, sine of x, not theta, sine of x. All right, the sine function starts at the origin. It goes up to 1 at 90 degrees. It goes back down to 0 at 180 degrees. It goes down to negative 1 at 270, back up to 0 at 360 degrees. Now, if you kept on rotating around the circle, this graph is just going to keep on doing this. It's just going to keep on going back and forth. If you rotate negative, it's going to keep on doing the same exact thing. This is what the sine function looks like if you don't have any restrictions. Now, a couple sections ago, we talked about functions being periodic. Look at this graph. The graph is repeating itself. It looks like waves in the ocean. All right? The graph repeats itself every 360 degrees, or every 2 pi. It starts at the origin, and it goes up, goes back down, back to the origin where the graph is increasing. That is a distance of 360 degrees. Okay, so that's the period of the sine function. But this is what the graph looks like. All right, if you need to copy that down, hit pause. Okay, let me go back to here, and let's talk about the cosine graph. Now, basic same setup here. So, on the unit circle, the cosine of an angle, that is your x-coordinate. So right now, our x-coordinate is at 1 when we're at a 0 degree. As we rotate to 90 degrees, our x-coordinate is going down to 0. As we go from 90 degrees around the circle to 180 degrees, our x-coordinate is going from 0 around to negative 1. Now we're here at this point on the unit circle. As we rotate around to 270, our x-coordinate is going to go from -1 back to 0, and then it's going to head back up to 1 as we get back to 360. So now, it looks basically the same thing as the sine function, and it really is, but it's shifted a little bit. So we'll talk about that here in a second. Let's go back to the notes. Okay, so now, for the cosine graph, y equals the cosine of x. The cosine function, it started at a y-coordinate of 1 at a 0-degree mark. And then at 90 degrees, it curved down to 0, down to 180 degrees at -1, back up to 0 at 270, back to +1 at 360 degrees. And this graph also, it just keeps on repeating itself every 360 degrees. Same thing's going to happen if we go negative angles. Down to 0, down to -1, back to 0, back up to 1. This will be at -360 degrees. So you can see it's just the same wave, just shifted a little bit. The sine function started at the origin. The cosine function starts at a +1 y value at the 0-degree mark. Okay. So again, if you need to copy that down, hit pause. I'm going to clear it so I can graph the next one. So now for the tangent function, completely different looking graph. Sine and cosine look exactly the same. It's this nice looking wave. The tangent function, totally different. All right. It took me a little bit of time to figure this graph out, but remember the tangent ratio is opposite over adjacent. And so I'm going to do the same thing. I'm going to rotate this around, and you got to think about the opposite side and the adjacent side of the triangle that's being formed here. That's where the y values are coming from. Oops. So as I rotate around, it's drawing this orange line. That's the y value for the tangent graph that's being graphed there on the right side of the screen. So as we go around, you can see how this graph is just completely different. Around to the 360. All right. There's a couple of different ways to think about it, and none of them are great ways to look at this, but the tangent function, in the right triangle, it's opposite over adjacent. And so when you divide those values at certain angle measurements, you're just getting these y values. And so what you have here, these are vertical asymptotes. All right, a vertical asymptote here, you got a vertical asymptote here. That's where this function is undefined. At 90 degrees, remember this point is 0, 1. So tangent's opposite over adjacent. That is your y value over your x value. 1 divided by 0 is undefined. That's happening here at 90 degrees. It happens at 270 degrees. So you've got some vertical asymptotes. But this is the general shape of your tangent graph. So let me draw a little bit more of it. Y equals the tangent of x. So at 90 degrees, vertical asymptote. At 270 degrees, vertical asymptote. Basically, every 180 degrees, there's going to be another vertical asymptote. So 180 degrees going in the negative direction puts us here at a -90, a -270. All right, these are the vertical asymptotes. The graph is this. It just keeps on repeating itself. So the tangent graph, it's repeating itself every 180 degrees. So we say it has a period of 180 degrees. You can see the graph, it's the same thing every 180 degrees. We're looking at the exact same thing. All right, that's what these graphs look like. I'm going to cut this video off here for this part. The next one is talking about some of the details and changes to these basic graphs that we just looked at. So please watch that one.